All right, today we're going to take a look at the lesson 3, lesson 4, and lesson 5 reviews for unit 4. These reviews will just cover the stuff that we did. It's not going to cover lessons 4.1 and 4.2. So just multiplying, dividing, adding, and subtracting rational expressions, as well as solving their equations. So we'll start off with the quick review. This is on page 234. To multiply rational expressions, what you're going to do is divide out common factors and simplify. So basically take out a GCF, factor quadratics, and then simplify. To divide rational expressions, multiply by the reciprocal of the divisor. And again, kind of sounds fancy, but really once we start doing it, you'll recognize what that's talking about. So the example that they're talking about is what is the quotient of this and this? The first thing you have to know is what quotient means. It means the answer to a division problem. If it was what is the product, that's the answer to a multiplication problem. So a little bit of vocabulary, make sure you know what that means. So what they did is they're saying the quotient of this and this. So they kind of skipped a step. They didn't set it up right as it's given. So you might be thinking, well, wait a second, why are they multiplying? We'll take a look. What they set up here in the quick review is multiply by the reciprocal, which is basically just the flipped version of that fraction of the divisor. So notice that they're dividing this second fraction, and then look from this step to this step, they flipped that fraction. So I like to write these all out, and I think I'm going to go ahead and do that just so everybody can follow along with those steps. So give me just a second to get this written out. All right, so here's that example written out as they gave it to us. Again, the quotient means dividing, so that's why I'm dividing those two fractions. My first step as I'm going through and setting this up is to always look for a GCF. Always make sure things are in standard form. So make sure it's x squared, x, then the constant. Don't have those things flipped around because it can be a little bit confusing if you do. If something's not in standard form, just put it in standard form. So GCF, standard form, and factor. So those are my first step, those three things. So if you need to write those down, you're more than welcome to. Otherwise, just kind of remember that or recognize that as we're going through this. GCF, standard form, and factor, all in the same motion. So I always start with the first fraction in the numerator. It looks like we do not have a GCF. It's in standard form, and it's ready to factor. So if I factor this, I'll draw myself a little X there. How do I know it's ready to factor? Well, because again, there's no GCF, it's in standard form because we have this X squared. If I have something like this denominator where it's just 2x plus 6, that degree for X is just to the first power. So I'm not going to have to use this X method with something like that. But if I have a quadratic where it's something like X squared like this, then I'm going to have to use my X method. I'm going to have to factor it. So at the top, A times C, the bottom is B. Two numbers that multiply to AC but add to B are going to be -1 and -1. At this point, this is where you would go and divide by A. But if I divide by 1, it doesn't change anything. It's still -1 and -1. So that's why I've always said if your A value is 1, you can skip that step of dividing by 1 because it's not going to change anything. But if I had something like 3x squared, well, then I'd have to go back and divide by 3 and simplify it that way. So for my numerator, what I have is going to be, let's go ahead and give myself some space. They're both -1s, so you could write it like this. Or you could have written it like this, x minus 1 squared. It's up to you, whatever you're comfortable with. Then my denominator is just x plus 3. There is no GCF. I can't do anything about that. There's nothing I need to factor or simplify, so I just write that down. I like to include parentheses around everything just because it shows me exactly what I can simplify out. This is where I'm going to go with keep, change, rearrange. Keep this fraction the way it was, change division to multiplication, and then rearrange that second fraction. So that goes back to that vocab word that they said, reciprocal. The reciprocal is just that fraction flipped. So 2x plus 6 will now be in my numerator. I've got a GCF there of 2, so I can take a 2 out. And then my old numerator will now be down in my denominator. I've got a quadratic, so I can go ahead and factor that. A times C is -4. My B value is 3. Two numbers that multiply to -4 and add to 3 are 4 and -1. And again, my A value is 1, so I don't have to go back and divide. It's still going to be 4 and -1. So x plus 4, because that's a positive 4. And then x minus 1, because that's a -1. Now with this step, everything's factored, everything's GCF'd, everything is simplified as much as possible. All right, I'm back. Sorry about that. I had to go answer the door and talk with somebody. I totally forgot where I was at. So let me just kind of keep moving forward based off what I have on my screen here. Keep in mind, everything at this point is factored and simplified. The only thing you can cancel from the top and the bottom of a fraction are common factors. The reason why I like to put those parentheses around it is because now I can visually see, oh, I've got 1, 2, 3, 4 things that I can cancel out of the top. I've got 1, 2, 3 things I can cancel out of the bottom. So again, I just prefer to use parentheses. So with what we have here, it looks like I've got an x minus 1 up top and down below, so I can cancel that out. I've got an x plus 3 up top and down below. Do not stay away from doing this, right? I've got an x here and an x here. I have to cancel out this entire factor, this entire thing that's being multiplied. I can't cancel out just something that's being added. It has to be multiplied. Same thing here. There's a 2 here, there's a 4 there. Don't think that that can simplify down to 1/2 because this is being added to a term. It has to be multiplied by something. So I think that's about it. Now the only thing I have left upstairs is a 2 times x minus 1. Downstairs is just an x plus 4. No more common factors in the top or the bottom. Let me check to make sure we don't have to state any domain restrictions. Nope, it was just asking for the quotient. So that would be my final answer. Now we'll move into some practice problems. So find the simplified product and state the domain. So obviously we'll be multiplying these things. They tell you that right there, but if they didn't tell you that, if there wasn't a sign there, then you'd know because they say find the simplified product that you'd be multiplying those. So I will move into 23. X squared plus x minus 12 over x squared minus x minus 6 times x plus 2 over x plus 4. So there's my problem. Again, my first step, I do all 3 of these things in kind of the same motion as I'm going through here. I look for a GCF, a greatest common factor. I look and make sure everything's in standard form. It starts off with the highest degree x, then it goes down to the next highest, then it goes all the way down to the constant. Same thing with these. Don't leave it as 2 plus x, right? Put them in standard form. So make sure those x's come first. I'm not seeing either one of those things. There's no GCFs and everything's in standard form, so I'm good to go. Now I'm just ready to factor. So there's a quadratic there, there's a quadratic there. Those are just binomials. They're good to go, so I'll just copy those down when it comes to it. So I'm going to factor my numerator, a times c at the top, b down below. 2 numbers that multiply to ac but add to b are going to be 4 and -3. So I will write x plus 4 times x minus 3. Then my denominator, same idea, a times c at the top, b down below. Two numbers that multiply to -6 and add to -1 are -3 and 2. Again, at this point, if that a value is something other than 1, I would have to go back and divide by that. If that was 2x squared, I would have to go back and divide by 2 and simplify. But since that's a 1, if I divide by 1, nothing changes. It's still a -3. It's still a 2. So I'm just going to write that. X minus 3, x plus 2. And then that second fraction, it's still an x plus 2 over x plus 4. Use parentheses, don't use parentheses, it's up to you. Just make sure you're canceling out common factors. Now everything across the top is being multiplied, everything down below is being multiplied. So we will take out common factors. Wow, so everything's simplified. So technically what we have here is just a 1. Then 24. So there's number 24. Again, we're multiplying. So I'm going to go through and I'm going to look for GCF, make sure everything's in standard form, and then factor everything. It looks like I have a GCF up here. So I've got an x that's common between those two terms. So I'll take out that x. And if I divide an x out of both of those, I'll just have x plus 8. Looks like I think I screwed that up. I think that's supposed to be an x cubed. Yep. Looks like I have an x in all three of those terms. So again, if I take an x out, I'll be left with x squared plus 5x minus 24. And then this, I guess you could call it this numerator. I've got an x in all three of those, so I can also take out or GCF out an x, and it'll be x squared plus 2x minus 15. And technically that has a denominator, right? So if you want to, you could write that over 1. If you don't want to, you can keep it like that. It's up to you. At this point, now I'm going to go ahead and factor these quadratics. So again, all I'm doing is drawing an x. Here's an example. A times c is -24. B is 5. Two numbers that multiply to -24 and add to 5 are going to be 8 and 3. So it's +8 and -3. And again, this a value is 1, so they're being super nice to you here. So I don't have to go back and divide by 1 because it'd be the same thing. So I have x times x plus 8. I've got that x, and then it's a +8, so x plus 8, a -3, so x minus 3. Then my numerator, the x that I GCF'd out, and then I will factor this as well. A times c is -15, b is 2. Two numbers that multiply to -15 but add to 2 are going to be 5 and -3. So that's going to be x plus 5 times x minus 3. Now everything is being multiplied, so I can cancel out common factors. So I'm going to take this x and this x plus 8 and x plus 8, x minus 3 and x minus 3. I don't have anything left in my denominator, so the only thing I have left is what's in my numerator, x times x plus 5. I like to leave everything factored out. Let's say this is a multiple choice test and they have some answers and that's not one of the answers. Well, then just try to distribute that x and get x squared plus 5x and see if that's one of your answers, right? Those two are the exact same thing, just one's distributed and one's, it's not factored out. So it's up to you. And then 25. So now we'll be dividing two fractions. So I'm going to go ahead and write this down. So for number 25, this is what we're looking at, dividing two fractions. Again, my first step is pretty much the same. I'm going to look for a GCF, make sure everything is in standard form, and then factor as well. Sometimes I'll just take the GCF and then I'll take the second step and factor, but those are my first top priorities, the first three things I like to do. This x squared minus 36, I can factor that. You can either do this. You can either factor it like this. A times c, that's -36, and technically b is 0. That's the same thing as x squared plus 0x minus 36. So I can do that, or you can do this. X squared minus 36 equals 0, and then solve it, right? Solve for X. Either way, you're going to get the same answer. So here it's going to be 6 and negative 6. There is no a value, or it's not, it's only a 1. So I'm going to leave it alone. So my numerator will be x plus 6 times x minus 6. My denominator, do the same factoring. I think I'm going to get an x minus 6 and an x plus 3. Here's that part where I'm going to keep, change, rearrange. Keep that fraction the way it is. Top stays up top, bottom stays in the bottom. Change division and multiplication, and now rearrange this. So it's called the reciprocal, basically flip it. So my old denominator is going to be the new numerator. So I'm going to factor that denominator. So that's going to be 3 and 4, x plus 3 times x plus 4. All I'm doing is this in my head. That's all I'm doing. And then the old numerator becomes the new denominator. So that's going to be x plus 6 times x minus 4. Now everything is being multiplied. So I take a positive 6 from the top and bottom, positive x plus 3 from the top and bottom, x minus 6 from the top and bottom. And the leftover parts are not identical. They have to be exactly the same. This is plus 4, this is minus 4. So there's nothing I can do. That'll just stay x plus 4 up top and x minus 4 down below. 26, another division problems. Oh, you know what? I just realized that in 23 through 26, they're asking for domain restrictions. So I'm going to go back to 23. Let's find it. There it is. My answer was 1 with 23, and my domain restriction, just to be clear what that is, you're basically saying I'm going to exclude any x value that's going to make my denominator 0. You can never divide by 0. So anytime you have a fraction, you have to look at your denominator. Anything that's going to make that go to 0, you have to exclude. I don't like looking at it at the beginning. I like to look at it at this step right here because everything is factored. Ignore the cross-offs, right? But everything is factored. Everything's ready to go. So my first domain restriction is going to be x minus 3. You could just think about it. Well, if I plug in a number for x, what minus 3 is 0? Most people would say positive 3. If you can't get that, if you don't understand that, doesn't make sense, just take each one of these factors and set them equal to 0. So x minus 3 equals 0, x plus 2 equals 0, and x plus 4 equals 0. Just take each individual factor, set them equal to 0, and solve. Here I would add 3, so I get x equals 3. Here I would subtract 2, so I get x equals negative 2. Here I would subtract 4, so I get x equals negative 4. So those are my 3 restrictions. I cannot include 3, negative 2, and negative 4. '24, same idea. You've got, technically this denominator is a 1, so this is the only thing you're worried about right there. Let's go through and see when we factored it. It looks like it's right here. So those are my 3 factors, the x plus 8, and the x minus 3. So if I set each one of these equal to 0, x equals 0, well, nothing to solve, right? It's just x equals 0. So I'd state x cannot equal 0. If I set x plus 8 equal to 0 and solved it, that would be negative 8. If I set x minus 3 equal to 0 and solve it, that would be x equals positive 3. So I have to exclude those 3 numbers. Your denominator can never be 0. All right, now we're caught back up. So for this, you're looking at both of these denominators, but I like to look once it's factored. So I'm looking at these 4 factors, x minus 6, x plus 3, x plus 6, x minus 4. So if I set each one of these 4 factors equal to 0 and solved, I would get x cannot equal positive 6, negative 3, negative 6, or 4. Now we're on to 26. So there is my number 26. Couple ways you can do this. You might notice kind of a little bit of a shortcut here. If I keep, change, rearrange this right off the bat, watch what happens. Keep that first fraction the way it is. Change division to multiplication, and then flip that second fraction, the reciprocal. So 3x plus 9 is on the top. 2x squared plus 5x minus 3 is down below. What do you notice? Well, you'll notice this quadratic is the same as that quadratic. So what you can do right off the bat, if you catch that, you can just cancel those out and move forward. In this case, it's asking for the domain restriction, so you're still going to have to factor this and come up with those factors. So it doesn't save you a lot of time, but it is good to kind of be looking out for that stuff to see if you'll be able to simplify that out. So I'm not going to cross those out. I'm going to go ahead and just come up with all the factors. So 2x squared plus 5x minus 3, there is no GCF, but I can factor it. 2 times negative 3 is negative 6. 5 is my B value. Two numbers that multiply to negative 6 and add to 5 are 6 and negative 1, but here's the difference. My A value is 2, so I have to go back over here and divide by 2 and simplify. Okay, just to re-explain, we've talked about this before, but why do we have to go back and divide by 2? Well, in the beginning, to get this AC term, we had to multiply 2 times negative 3. So I can't just randomly multiply numbers together if I don't have an equation. So what I have to do is kind of undo that and go back and divide by A to kind of undo what we did at the beginning. So my numerator is going to be x plus 3. And here's my bottoms up part. This denominator is going to come up as my leading coefficient. So negative 1/2 becomes 2x minus 1. This denominator, if I set it up with my cross method and factored it, I would get negative 7 and 3. My numerator, I take the GCF. I can take out a 3. And then my denominator was exactly the same as my numerator, so I'm just going to rewrite that first numerator. Now everything is ready to factor. I've got an x plus 3 up top and down below, a 2x minus 1, and that makes sense, right? Because we said that at the beginning. I've got an x plus 3 up top and down below, and everything else are just leftovers. So up top in my numerator, I've got a 3. Down below, I have an x minus 7. And then now I'll state my domain restriction. So I'm looking at this step right here. I can never have a denominator that equals 0, but don't forget, this is really unique. And I might have forgotten it with the last problem. So let's go back up and take a look at that. I'm dividing these two fractions. So remember, I had my 2 original denominators, right? Then I keep, change, rearrange. So I flipped it. So my original denominator is now up here. My new denominator is now down here. So really, I've got 3 places I have to look for exclusions. So we'll go back up to 25 and double check that. So I have to exclude numbers from this numerator, this denominator, and this denominator. Because this numerator used to be in the denominator, I still have to exclude that. So I'm looking at those 3 places right there. Up here, 3 just can't randomly equal 0, so I'm not worried about that. X plus 3, that would be a negative 3. Down here, that would be a 7. That would also be a negative 3. I've already got it listed. That would also be a negative 3. I've already got it listed. And then this would be a positive 1/2. So how did I get that? Remember, you can just take 2x minus 1, set it equal to 0, and solve it. Okay, so that would be my final answer. Let's go back up to 25. Man, that not doing the domain restrictions kind of screwed me up. I took care of my two denominators, but remember we started off with a division problem. So these were my two denominators. Then when I keep, change, rearrange, I've got a new denominator and my old denominator is now upstairs. So I've got to make sure that those are excluded as well. So that would be a -3, which it is. That would be a -4, which I did not have. So I have to add that on there. (27), the volume, and let me go ahead and put this on the screen. The volume in cubic units of a rectangular prism with a square base can be represented by this. The height can be represented by x plus 8. What is the side length of the base of the rectangular prism in units? So for 27, I went ahead and set this up. It's talking about volume. So we know that length times width times height is my volume. The way I wrote it is the area of the base. So length times width, that's the area of the base, times my height is volume. They're telling me that my base is a square. So I know that both my length and width are the same exact value. So we'll deal with that later on though. So I've got the area of the base times height equals volume. All I did was replace what I knew. My problem told me the height, it told me the volume. Now we just have to solve for the area of the base. So this is base times height. So what I can do is I can move that x plus 8 to the other side by dividing it by both sides. So now I have base equals this. So when I go to rewrite this, I'm going to go ahead and take out some GCFs and kind of simplify this a little bit. So the area of my base is going to be, I could take a 25 out. That has 3 x's, that has 2 x's. So I can also take out 2 x's. So what's left over? I think this is just going to be an x. 200 divided by 25 is 8. If I took out the x squared, all that I'll have left is just the 8. And my denominator is x plus 8. At this point, I've got common factors in the top and bottom. So let me clean this up again. B equals 25x squared. I think the easiest way to kind of explain this is just go back and reiterate what base represents, what this B represents. They're telling me that what I'm dealing with this prism is it has a square base. So both the length and the width are exactly the same. So just kind of keep that in mind here. What I can do is I can just square root both sides. Let's write it like this. Let's write it like length times width equals 25x squared, okay, instead of B, because that capital B represents the area of the base, which is length times width. Since we're dealing with a square, let's, instead of dealing with two different variables, let's call it one variable. It doesn't matter. You can call them both length or both width. Since it's the same value, it doesn't matter. It's up to you. I like to write W, so I'll write W squared. So all that's exactly the same. Now, the reason I did that is now when I take the square root of both sides, it kind of makes a little more sense. The square root of W squared is just W. The square root of 25 is 5. And the square root of x squared is x. So what they're saying here is that both W and L, because it's a square base, so both the length and the width, right? Both directions are both 5x. So that would be my common, or that would be my answer. Let me make sure. Base, rectangular prism. Okay, I just want to make sure there was no domain restrictions or anything like that. So that wraps up 4.3. 4.4, this is all about adding and subtracting rational expressions. So a quick review: to add or subtract rational expressions, multiply each expression in both the numerator and the denominator by a common denominator. Add or subtract only the numerators. I want to re-emphasize that. When you're adding and subtracting common fractions with common denominators, you're only adding and subtracting just the numerators. The denominator stays the same. So 1/5 plus 2/5 is 3/5. It stays fifths all the way through. Then simplify. So this example, what is the sum? So I know that they're adding these things because the sum is the answer to an addition problem of this plus this. So they start off with x minus 2, but all they did was just they factored out the x squared minus 25. So they drew an x and they found their AC term, their B term, found two numbers that multiplied to AC and added to B, and they came up with the factors. The second fraction is exactly the same. What you're looking at now is you've got a better idea of what those common denominators have to be. If this has an x plus 5 and an x minus 5, this has an x plus 5, what's it missing? It's missing the x minus 5. So this fraction is good to go. Nothing's going to happen with this fraction because what I can do is I can multiply the second fraction by an x minus 5 right here, x minus 5 over x minus 5. Now look, they have common denominators. Just make sure when you're multiplying those, whatever, the binomial, the monomials, whatever you're multiplying, make sure you multiply both the top and the bottom by whatever that GCF that you need is. Just a quick heads up, I already talked about this in lesson 4.4. Anytime you're dealing with a problem that has a binomial in the denominator, that's essentially what you're going to have to do. You're going to have to basically multiply this fraction by what it's missing compared to the other denominator. There's no other way around it. So now I've got two fractions with like denominators, so I can technically add those numerators. So that's what they did here. They took x minus 2, they added 3 times x minus 5. All they did was just some algebra, distributed that positive 3, combined like terms. At this point, there's nothing to GCF, there's nothing to cancel out, so that would be my final answer. Find the sum or difference. So the sum is the answer to an addition problem. The difference is the answer to a subtraction problem. So that's what we'll do. So for 28, kind of like I talked about a minute ago, this is a problem where your denominators are binomials. You've got two terms in these denominators. So it could be like this one where both denominators have two terms. It could be something like where only one denominator has two terms. Either case, it doesn't matter. You're going to basically have to multiply by the other denominator. There's no way around it. So in this case, this denominator is x plus 6. So I know I'm going to have to multiply the second fraction by x plus 6 over x plus 6. This denominator is x minus 1. I'm kind of going to squeeze this in here. So I know I'm going to have to multiply the first fraction by x minus 1 over x minus 1. Sorry about squeezing that in there. Now I'm ready to go. So what I can do is start multiplying these. Technically, now my denominators are the same. This denominator is x minus 1 times x plus 6. This denominator is x minus 1 times x plus 6. So what I can do is I can combine these two fractions. So it's going to be 2x times x minus 1 plus 3 times x plus 6. And they both have the common denominator of x minus 1 times x plus 6. So now is that algebra part. I'm going to distribute the 2x, distribute the 3, combine like terms, simplify if I can. So if I distribute my 2x, I'll have 2x squared minus 2x plus 3x plus 18. At this point, then I'll have, if I combine like terms, I'll have 2x squared plus x plus 18 over x minus 1 times x plus 6. Now I've got a quadratic up in my numerator, so I know I'm going to have to factor it. 2 times 18 is 36. B value is 1, not 0. Two numbers that multiply to 36 and add to 1. 9 and 4, 6 and 6, but they're not one apart. I think that's it, right? Obviously, like 12 and 3. I don't think there's anything else. So technically, this quadratic can be factored using the quadratic formula, but it's not going to give us nice even numbers. So I'm going to leave that quadratic the way it is, box it off, and move on. Now we'll take a look at 29. 29, you're subtracting two fractions. Again, what I like to do is always take GCFs. If you can simplify an individual fraction, that's a great idea. You know, factor the quadratics, all that kind of stuff. I think my denominator can be factored. That's about it. Everything else is going to stay the way it is. So this denominator, if I factor it, that's going to be x plus 2 times x minus 2. Now, if I look to see, this is a lot like our example problem that we saw. They both have an x minus 2 as a factor, but this one over here doesn't have that x plus 2. So I'm going to have to multiply both the top and the bottom by x plus 2. Now they both have common denominators, so I can just subtract the numerators. So it's going to be x minus 5 times x plus 2 over that common denominator. Just like before, now's the point where we distribute that -5, combine like terms, simplify, all that kind of stuff. So I'm going to distribute the -5. It'll be x minus 5x minus 10. X minus 5x, that's going to be -4x. And of course, if you're doing this work, you don't have to show every single step like I'm doing. Now I'll take that GCF. I always want that leading coefficient to be positive. So I think in this case, I'm going to take out a -2. So that'll leave me with 2x plus 5. I think that's it. I've got a -2 up top, no factors of 2 down below. There's a 2x plus 5 up top, not in the bottom, and that's it. So that would be my final answer. Nothing to simplify out. 29. So then we got 30. So these are those fractions within fractions. I'm sure you've heard me say this before. There's always different routes that you can take to solve this type of problem. You know, there's different things you can do as a first step, or, you know, even mix up the steps and do different things at different times. So if you have a different method for doing these types of problems, awesome. That's great. Just make sure, you know, whatever you're doing is mathematically sound and you understand how it's working. If not, just contact me and I'll look at your method and we'll take a look at it together and I'll help you out. So what I like to do is, since I have two fractions in the top, two fractions in the bottom, I'm going to find a common denominator with both the top and then the bottom. They could be the same common denominator. You could find one common denominator for everything. You can find just a common denominator for the top and the bottom. I mean, it's up to you. Again, I'll just look at the top. So ignore the bottom for a second. This top is technically 2/1, which is why I said we had two fractions up top. This denominator is an x, so I know I'm going to have to multiply that first fraction by x over x. Now what I have is 2 times x plus 2 over, this was over x, so this has to be over x as well. My denominator, again, very similar to the top. That denominator is a 1. This denominator has an x. So what I'm going to do is multiply that first fraction by x over x. So I have 2x minus 2 over x. And here's the part where you can do what they call, again, we've talked about it before, keep, change, rearrange. So this is 2x plus 2 over x divided by 2x minus 2 over x. So I'm going to keep that first fraction the way it is. Change division to multiplication, and then rearrange the second fraction. Flip it. At this point, you want to cross off common factors, so I can cross out the x's. I'm going to take these GCFs just to clean it up a little bit. So I'll take that 2 out. That'll be x plus 1. I'll take this 2 out. So that'll be x minus 1. Once I took those GCFs, now I found another common factor. And this has to be my final answer. X plus 1 over x minus 1. Oh, 31. Same idea as before. Some people like to find a common denominator from everything. I like to break it up because sometimes that's too big of a picture to take in. So I like to look at just that numerator, right? Ignore the denominator, come up with a common denominator just up top. This has an x, this has a y. The only way to get a common denominator is if they both have an x and a y. So what I'm going to do is I'm going to multiply this first fraction by y over y, the second fraction by x over x, and I think that'll do it. Same thing with the denominator. This has an x, this has a y. The only way to have a common denominator is if that common denominator has an x and a y. So I'm going to multiply this by y over y, this by x over x, and then write everything down. Y times -1 is -y. 3 times x is 3x. And then that common denominator of xy. Y times 4 is 4y. -5 times x is -5x. And then that common denominator of xy. So now I can do keep, change division to multiplication, and then flip that last fraction. So I'm just going to use this first part right here just so I don't have to write some more. Keep that the way it is, change division to multiplication, and then flip that second fraction. So really, I'm kind of ignoring this at this point. I got an x and a y up top and down below. I like to put things in alphabetical order, so I'm going to go ahead and just rewrite this real quick. So I'll write that as 3x minus y over -5x plus 4y. I don't think there's anything you can GCF out. I'm not seeing anything. There's nothing I can simplify and, reduce down. So I think what I'm going to do is leave it at that. 32, why is it necessary to consider the domain when adding and subtracting rational expressions? Don't forget what's the purpose of a domain. A domain basically states any values that you can, that function, that expression can accept. It can also put domain restrictions on it. So you could basically say that function cannot be divided by 0. So for example, if we take a look at 28, if they were asking for domain restrictions, which they didn't, I would say -6 and +1, because if this was -6, then it would be 2x divided by 0. You can't divide by 0. So the important thing about domain restrictions or domains when adding and subtracting is you can never divide by 0. Also, when you're adding and subtracting, I'm back. Sorry, doorbell rang again. Somebody at the door. And I forgot what I was saying. I think we're on question 32. Why is it necessary to consider domains? I think what I was about to say was just keep in mind when you're adding and subtracting fractions, I can't do something like this. If I have like 3x over 7 plus 5x over x, I can't just straight up add these together. So that's not 8x over 7x, right? They have to have common denominators. So these denominators have to be the same before I can add the numerators. And then also keep in mind, once my denominators are the same, then all I'm technically doing are adding the numerators. 3x plus 5x is 8x, and it's still over 7. So 33, make sense and persevere. Mia. paddles a kayak 6 miles downstream at a rate of 4 miles per hour faster than the river's current. She then travels 6 miles back upstream at a rate 2 miles per hour faster than the river's current. Write and simplify an expression for the time it takes her to make it round trip in terms of the river's current C. All right, for 33, I went ahead and set up this problem. Let me just kind of explain where I got these numbers from. So the problem was asking for her total time for the round trip, right? So for the time it takes her to make the round trip in terms of the river's current C. So that's why I'm adding these two fractions, because I want to talk about going downstream and then upstream. It's saying that she paddles 6 miles downstream. So that's where the 6 comes from. That's how far she went downstream at a rate of 4 miles per hour faster. So while she's going downstream with the current, she's going 4 miles per hour faster. So that's why I added 4. And then she travels 6 miles back upstream. So that numerator is 6 at a rate of 2 miles per hour faster than the river's current. So why am I subtracting? If she's going upstream, she's going slower, right? So she's fighting against the current. So I want to subtract that too. Now I've got two fractions. I've got unlike denominators. So what I can do is just get common denominators. This goes back to the problems that we already did where my denominators are binomials. So I know the only way out of this situation is if I multiply each of these fractions by the other denominator. So this first fraction, the other denominator is c minus 2. So I'm going to multiply the top and the bottom by c minus 2. The second fraction, the other denominator is c plus 4. So I'm going to multiply the top and the bottom by c plus 4. And then let's see what we get. Up top, I've got 6 times c minus 2. So in this step, I'm going to go ahead and distribute that. So I'll have 6c minus 12. Same thing with the second fraction. I'll distribute that 6. So it'll be plus 6c plus 24. And then my denominators are now common. C minus 2 times c plus 4. C minus 2 times c plus 4. So this has to be c minus 2 times c plus 4. Now I've got common terms in the top. So 6c plus 6c is 12c. Negative 12 plus 24 is 12. These parentheses and c's are throwing me off. I could take a GCF out of the top. So I'll take out that 12. It'll be c plus 1. C plus 4. Doesn't look like there's anything I can factor out. So I would state that that's my final answer. So that is 33. So that wraps up lesson 4.4. Now let's take a look at 4.5. This was all about equations. So if you look in the review, a rational equation is an equation relating rational expressions. So you're just adding or subtracting rational expressions together. But now you have an equation, so now you can actually solve for x. Another vocab word, an extraneous solution, is a value that is a value that is a solution to an equation that is derived from an original equation but does not satisfy the original equation. So hopefully I'm sure we'll see an example of that, but an extraneous solution might be if you have a problem like this, you solve it and get 2 different answers, like x equals 2 and x equals 4. But once you verify if those answers are acceptable by looking at the denominators, you find out that 2 is not acceptable because 2 minus 2 is 0. So you'd have to x out 2. But 4 would still be good to go. So 2 would be called an extraneous solution. With this example, it looks like we don't have any common denominators. What are they doing? It looks like they're coming up with, well, it looks like they're skipping some steps and it might be a little bit hard to follow. So I think I'm going to go ahead and write this out. Give me just a second. So here is the example in 4.5. Just like I said before, lots of different ways you can do it. You could find a common denominator which it looks like that's an x minus 2, that's an x minus 2, that's a 4. So my LCD, my common denominator, would be a 4 times x minus 2. The other way I think I'm going to do it is I'm going to go ahead and subtract this term over to the left side. So I'm going to subtract x over x minus 2. So on the left, I'll have 2 over x minus 2 minus x over x minus 2 equals negative x over 4. Now I have common denominators, so I can add these numerators. 2 minus x, that would just be 2 minus x. I can't combine those, but I'm going to flip them. So that's going to be negative x plus 2 over x minus 2. Now I'm down to a single fraction equal to a single fraction. So we can do this thing they call cross multiply. So I'm going to multiply those two diagonals. So it's going to be 4 times negative x plus 2. And that's going to be equal to that diagonal, negative x times x minus 2. Doesn't matter where the negative goes. You could have put it with x. You could have put it with negative 4 over here. Just make sure it goes with one of them. It doesn't matter. In this case, I am ready to distribute and multiply these things out. So distribute that 4, that's negative 4x plus 8 equals negative x squared plus 2x. What I'm seeing here is a quadratic, so I know I'm going to have to set this equal to 0 and factor it. So I'm going to add x squared to both sides. I'm going to subtract 2x from both sides. So that leaves me with x squared minus 6x plus 8 equals 0. Now I'll factor 8 in the top, negative 6 down below, negative 4, negative 2 are my numbers. So it's x minus 4 times x minus 2. And then my two answers are going to be positive 4 and positive 2. Don't box it off and move on yet, because we had fractions. You have denominators where you have to plug those in and check them for extraneous solutions. So our two answers are 4 and 2. If I plug in 4, 4 minus 2, that's 2. 4 minus 2 is good. Perfect. If I plug in 2, 2 minus 2 is 0. So this is an extraneous solution. Leave it on your paper. That's cool. Just cross it out. 34. 18 over x plus 4. This should be pretty quick to write down. Okay. Is that 18? Oh, I don't know where I wrote 18. 34. This is 34. 34. Sorry. Number 34. 18 over x plus 4 equals 6. I like to think about this as two separate fractions. So what I do is that cross multiply like I did in that previous step. So it doesn't matter which diagonal you multiply first. I can do 6 times x plus 4 equals 18 times 1 is 18. Or you could have gone 18 first. It doesn't matter. So now it's just algebra. Distribute my 6. Solve for x. So I'm going to subtract 24 from both sides. Divide both sides by 6, and I get x equals negative 1. Again, double check, make sure if you plug that in, it doesn't give you a denominator 0, which it doesn't, so we're good to go. We'll keep that. 35, 9 over x minus 1 equals 3. Same situation. I'm going to think about this as 3 over 1. So I'll do the cross multiply. The only time you could do the cross multiply is if you have a single term equal to a single term. So if I had two fractions over here, I couldn't do cross multiply. If I have one fraction equal to one fraction, I'm good to go. So I'll have 3 times x minus 1 equals 9. Just like before, distribute that 3 and then solve for x. Make sure if you go back and plug that in, it doesn't give you an extraneous solution. So we are good. That does not. 36. Getting a little bit more complicated. Negative 4/3 plus 2 over x equals 8. This is a situation where I could not just cross multiply and be done because I've got two terms on the left-hand side. If I had just the 2x, I'd be able to, but not if I have more than that. So just one single fraction is good to go. So what I would do is come up with a common denominator on the left, add those two fractions together, then do the cross multiply. This is a 3, this is an x, so I know that what I'm going to have to do is multiply. Again, you could do what we have been doing where I multiply this fraction by x over x, this fraction by 3 over 3, and then move forward. You can come up with that common denominator and then multiply the entire equation, everything, both sides, everything by that common denominator. So I think that's what I'm going to do. Essentially, what I'm going to do is distribute this 3x to all three of those terms. So 3x times 4 is 12x. Actually, I'm going to write it like this. I'm going to keep that 4 separate. And that's over 3. And that's a negative. I don't want to lose that. Plus 3x times 2. And that's over x equals 3x times 8. And I'll go ahead and multiply that together because I'm not going to have to do anything with that. The reason I multiplied the entire equation by that least common denominator, first of all, is because it's an equation. I can't just multiply the left side or one single term inside that equation by something. If I want to multiply something by 3x, I have to multiply everything by 3x. The other reason I did that is because watch what happens. I've got a 3 up top and a 3 down below. I got an x up top and an x down below. So what essentially happens when I distribute that 3x, all it's going to do is just cross out that denominator as well as something from that least common denominator and leave me with numerators. So negative 4 times x plus 2 times 3 is 6 equals 24x. So I multiplied everything by that common denominator and then simplified. Now I have this. So I'll add 4x to both sides. So I get 6 equals 28x. Divide both sides by 28. Would that be 3/14? 3/14 equals x. Let me just double check. When I see fractions, it just makes me nervous. I want to make sure I did everything correctly. So that would be negative 4x. That would be 6. That would be 24x. If I added 4x, that's 28x. Yep, so that looks right. And again, that fraction does not make that denominator 0, so we're good to go with that. 37, 2x over x plus 3 equals 5 plus 6x over x plus 3. We saw an example of this earlier. I can't remember where it was at, but basically I've got fractions on either side of the equation where they have common denominators. So what I'm going to do is I'm going to go ahead and subtract this 6x over x plus 3 from both sides. That way I'll have two fractions with common denominators on the left. And then that 5 on the right. So on the left, we have two common denominators. So if I subtract them, 2x minus 6x is negative 4x. I've got two fractions, one on each side, so I can do that cross multiplication. So 5 times x plus 3 equals negative 4x times 1, which is just negative 4x. Now distribute, combine like terms, solve for x. So if I distribute my 5, I'll have 5x plus 15 equals negative 4x. I'm going to subtract 5x from both sides. Divide both sides by negative 9. And then I have negative 5/3 equals x. And again, that does not make one of my denominators 0, so I'm good to go. $38. Pretty much exactly the same as before. I'm going to do the same exact thing. I'm going to go ahead and subtract 64 over x minus 8 from both sides. And that leaves me with negative 8 equals x squared minus 64 over x minus 8. Remember, I'm subtracting two fractions. Both fractions have a common denominator, so I can just add their numerators, or in this case, subtract them. X squared minus 64. The common denominator is x minus 8. I got two fractions, one on each side. I'll do that cross multiplication. So negative 8 times x minus 8 equals x squared minus 64. Distribute, combine like terms, solve. I'm seeing an x squared, so I know I'm going to have to factor this. So let's distribute the negative 8. And then I'm going to go ahead and move everything over to the right. So I'll add 8x to both sides, subtract 64 from both sides. And I have 0 equals x squared plus 8x minus 128. Go ahead and factor this because I've got a quadratic, so that's the only way out of it. A times c, that's negative 128. B is 8. 64 and 2, 3. So this is obviously a big number, right? So I want to give everybody, just to reiterate how you can approach these if you don't know how to factor them. Take that number, 128. At this point, I don't really care that it's negative. I just want to find factors of 128. And then I'm going to list out those factors. Well, 1 times 128. Well, it doesn't matter if I add or subtract, positive or negative. There's no way they're going to get to 8. 2 and 64. Again, positive, negative, doesn't matter. They're not going to get to 8. So all I'm doing is 3, 4, 5, 6, 7, 8. I'm just coming up with these factors and seeing, well, what about 3 times something? 3 times 40. Nope, that doesn't work. So I'm going to skip that. That doesn't matter. 4 times 32. 4 times 32 is 128, but still they're way too far apart to give me 8. 5 isn't going to work, so we'll ignore 5. 6 isn't going to work, so we'll ignore 6. 7, that's 758. No. Right? Let me make sure I'm not screwing that up. 128 divided by 7. Nope, that's a decimal. So this isn't going to work. 128 divided by 8, that's 16. So take a look at what I have now. 8 and 16 multiply to 128, and 8 and 16 are 8 apart. I just have to figure out which one has to be negative for it to be able to add to 8. So I think that is my situation that I have here. It's got to be a negative 8 and a positive 16. So I've got 0 equals x minus 8 times x plus 16. So my two answers are going to be x equals 8 and x equals negative 16. Make sure that those don't violate any, any denominators. 8 and 16. If I plug in 8, 8 minus 8 is 0. So that's going to give me an extraneous solution. So I don't want to include that. I only want negative 16. We'll do 39. 39 is already set up as two separate fractions, right? One on each side. One fraction on the left, one fraction on the right. So now I can just cross multiply. So it doesn't matter which one you do first. I'll do that one. 3 times x squared minus 9 equals 9 times, I think what I'm going to do just for the sake of keeping this clear is I'm going to go ahead and distribute that inside those parentheses. So that's 6x minus 18. So I'll do 9 times 6x minus 18. I didn't want to have parentheses inside parentheses. That can get a little bit confusing. Now I'll distribute. So that's 3x squared minus 27 equals 54x minus 90, 72, 162. Hope I didn't screw that up because then it's going to screw everything else up. 90, 72, 162. I think that's right. I see a quadratic, so I know I'm going to move everything over to that side. So I'm going to go ahead and subtract 54x and then add 162 to each side. So that gives me 3x squared minus 54x. Negative 27 plus 162, that's 140, 135. I think that's right. And that's equal to 0. It doesn't look like there's a GCF. Wow, this is a doozy. So I'm going to go ahead and factor this. 3 times 135 is going to be 390, 405. Negative 54 down below. So give me a minute. I'm going to come up with these two factors. All right. After I struggled with that for a little bit, I thought I had it, but the two numbers that I thought would work didn't. So then I came up with 45 and 9. So 45 times 9 is 405. 45 plus 9 is not negative 54. So that means they're both going to have to be negative. Now we should be good to go. At this point, a was 3, so I have to go back and divide both of these by 3 and simplify. So negative 9 divided by 3 is negative 3. Negative 45 divided by 3 is negative 15. So my answers are going to be x equals positive 15, and then x equals positive 3. Remember a little bit of a shortcut there. Once you come up with those two numbers, you can always come down here and just take the opposite of those two numbers, right? In this case, 15 is going to work, but I don't think 3 will. If you go back up here and look, 3 minus 3 is 0. 6 times 0 is 0. That's going to cause a mess down there. So I'm not going to be able to include 3, but 15 will work. 39, 40. Explain how to check if a solution is to a rational equation is extraneous. We've talked about that, and we actually just did it. We did this problem, we worked it out, we got two numbers, but the problem is once you go back up here and plug in those two numbers, it doesn't end up working. So 3, when you plug it in, 3 minus 3 is 0. So anything that's going to give your denominator a 0 doesn't work. 41, Diego and Stacy can paint a doghouse in 5 hours when working together. Diego works twice as fast as Stacy. Okay, so this is the one where it's like fractions. So let's take a look at this. Diego and Stacy can paint a doghouse in 5 hours when they're working together. So if you take their two amounts and you add them together, they'll be able to do that in 5 hours. Diego works twice as fast as Stacy. So that's important to note. Let X be the number of hours it would take Diego to paint the doghouse, and Y be the number of hours it would take Stacy to paint the doghouse. How long would it take Stacy to paint the doghouse if she was working alone? And then also, how long would it take Diego to paint the doghouse if he was working alone? So this problem is a little bit different than the problem that they gave you in the practice or in our section in 4.5. Because they're specifically telling you that they want you to use X for, let X be the number of hours it would take Diego to paint the doghouse. So, you know, we don't really have any options here with how to set up. So get common denominators. Again, however you want to do it, it's completely up to you. You can get a common denominator for the entire equation. You can get a common denominator for just the left side, then add those together, then cross multiply. It's really up to you. Let's get a common denominator for the entire equation because I feel like we've seen the other one a lot. So I'm going to multiply this entire equation by something, and it's going to be, that something is going to force everything to have a common denominator and basically let all those denominators disappear. So if this is a 2x, I know that I'm going to have a 2x here. Okay, that's the only thing that I'm going to have to multiply throughout here that's going to let me cancel out that denominator. So if I take this 2x and I multiply it to the second term, it's also going to let me cancel out that x. I'll have a 2 upstairs, but that's okay. I don't care if I have extra upstairs. All I'm focused on is getting rid of the denominator. So far, the 2x will get rid of the denominator in the first problem or the first fraction. The 2x will get rid of the denominator in the second fraction, but it's not going to get rid of the denominator in the third fraction. So what I need to do is bump this up by a multiple of 5. So 5 times 2 is 10. So let's change that to a 10. Let's double check. 10x, if I distribute that, 10 divided by 2 is 5. So I'll have a 5 upstairs, and then the x's will cancel out. So that's still good to go. 10x to this one, the x's will still be able to cancel out. And then the 10x to this one, the 5 and the 10 will be able to simplify down to a 2. So I'll have a 2 upstairs. So that's good to go. So that's what essentially I'm going to do. I'm going to distribute that 10x to all 3 terms. And I'll go ahead and just write that step out. So 10x over 2x plus 10x over x equals 10x over 5. At this point now I can simplify. So I can take an x from the top and the bottom. 10 divided by 2 is just 5. I can take an x from the top and the bottom. And then I can do 10 divided by 5, which is just 2. So what you'll notice is no more denominators, just numerators. So upstairs, I've got a 5. Here, I've just got a 10. And then here, I have a 2x. So if I simplify that, that's 15 equals 2x. Divide both sides by 2. You can leave it as 15 halves, or you could write it as 7.5 if you're more comfortable with a decimal. That's up to you. So x, that tells us, what was that again? Where am I at? Here we go. X represents the number of hours it would take Diego to paint the doghouse. And then if you look back in the problem, so basically this is saying that Diego can paint the doghouse in 7.5 hours all by himself. If you look back in the problem, they're giving you another piece of information that Diego works twice as fast. So this time right here, that's twice as fast as what Stacy would work. They're telling you let Stacy have equal y. So if this is twice as fast, what I have to do is I have to multiply 7.5 times 2 to get Stacy's time, right? This time is twice as fast. So 2 times 7.5 is 15. So there's the 2 times, Diego all by himself, Stacy all by himself. You could have set this problem up originally for Stacy as well in terms of y. That's just a different way you could have done it. If you wanted to do it that way, it's completely up to you. If you have any questions or problems, make sure you email me, let me know as soon as possible, and I'll be here to help.